So this is an electrolysis question, and the first bit says, where is copper formed during electrolysis? And if you remember our core knowledge, copper is a metal, and metal always form cations, and cations always go to the cathode. So the only sensible option there is cathode. A student investigated a change in mass. The results are shown below. State and explain the trend. So the trend here you can see is as the current is increasing, the mass of copper is also increasing. So here the trend is as the current increases, the mass of the cathode increases. Okay. Or in fact, actually, let's change that because it does actually say specifically copper. So let's make that the mass of the copper increases. Okay. So that gets us 1 mark. Then it says explain the trend. So I'm just going to write down here that if you have copper ions, they are looking to gain electrons and form copper. Now, when we increase the current, remember, current is a flow of electrons. We have more electrons. So if I have more electrons, therefore, more copper ions can react, and they will form more copper. And that's what we've got to put into words. So we say here that as the current increases, there are more electrons This means more copper ions can react to form copper. Okay, and marks wise, we get a mark up here for saying the trend, and then these 2 bits here are the explain section of that. Okay, describe how the mass of copper can be measured. Right, so what we have to do here is leave the cathode to dry, because once it's been in the electrolyte, it'll be damp, and that will change the mass. So we leave the cathode to dry, and then we find its mass using a balance. Okay. Right, next question is a calculation. And there's a number, they're giving a lot of marks to this calculation. There's a number of steps and a number of traps in here that we could fall into. What I've done is I've put down 2 triangles that we're going to use today. So we've got Mr. Moles, and we've got the number of particles is moles times AC. Now the first trap to be aware of is we have got 74 milligrams of this copper. What we have to do first of all is convert that into grams. So what we have to do there is 74 divided by 1,000, and that's given me 0.074, and that's now grams. I need that to be in grams in order to work through the rest of this. So I've got 1 mark already. Now then, grams is fine, but what I want to do is convert that into moles. So let's call that step 1. Step 2 is finding the moles of the copper, and according to that triangle, moles is mass divided by mR. So the mass in this case is that 0.074, and the mR tells me in the question is 63.5. So let's do that. Divided by 63.5, and that's given me 1.1. I'm going to put 65 times by 10 to the minus 3 moles. So that's the second stage done. And again, we've got ourselves a further mark in there. And then the final little bit is using the number of particles equation. So number of particles equals moles. I'm going to write something underneath here, so otherwise I get squashed. 1.165 times by 10 to the minus 3. times by Avogadro's constant, which is 6.02 times 10 to the 23. So let's times that out, times 6.02, that to the 23, and that's going to equal 7.0, I'm going to call that 0.2 times by 10 to the 20 atoms.